Okay, I'm going to do the answers to these here. Also, your study guide will be as a photo attachment with this as well. That you'll do after you do this. Watch this video and check your answers. The study guide goes back to the beginning of the triangles as far as naming them, like scalene, isosceles, equilateral, or by their angles, acute, obtuse, or right. And then it goes back to finding the missing angle, whether it adds up to 180. And so it goes back to those things, and then it gets into the Pythagorean theorem. Then the next day there'll be a video answering the study guide, and then the test will be after that. So just be watching for that. Here is these here. Now some of these have the hypotenuse missing, just like you did yesterday, but then it gets into what happens when there's a leg missing. So let's go through that. Now here's the first one: is the hypotenuse is missing, just like they were the day before, and you're going to do 5 squared plus 2 squared equals c squared. Now, here's where I was made. It doesn't matter what order you put those in. Here's the 2 legs, so you just put those and you add them. So 25 plus 4 equals c squared, so 29. And then you just need to square root 29. So we're going to go here. I got my bigger calculator here, 29, and then square root. Okay. And so it's 5.4 rounded to the nearest tenth, so 5.4. Okay, so let's put that on there, 5.4. Okay, here's 1, 3, and 10. It's also the hypotenuse is missing. That's the one across from the right angle. So 3 squared plus 10 squared equals c squared, 9 plus 100. And so 109. And so we square root 109. And that's 10.4 rounded to the nearest tenth. Okay, now here's one that's missing the leg. Not the here's the hypotenuse. We know it. We're just missing one of the legs. And whether you make that the A or B, it does not matter. So we'll make this one the A that's missing. So a squared plus 3.6 squared equals 7.4 squared. So what we did is we've got our C, so we don't leave that unknown. That's going to be here. But make sure you square it. And then you square, if you made that your B and you're missing A here. So let's do 3.6 squared and see what that is. 3.6 times 3.6 is 12.96. Okay, and then let's do 7.4 squared. And if you're doing it by hitting the squared, you can hit this squared button. It's 54.76. And then you still are missing your A squared, and that's what you're solving for. Now, what that means is you got to do one extra step, and that's move this over here so you can isolate that unknown. Okay, so A squared is going to be, let's subtract 12.96, 31.8, okay, 31.8, and now you just need to, you still need to square root it though. So A equals, and we're going to square root 31.8 is 5.6. Okay. So just one extra step when you're missing the leg. You just have to move the leg over there. So let's do this one. And this one, I'll show you, it doesn't matter whether you make this A or B. Here was the right triangle. There's the hypotenuse, 3.9 squared. So we'll make that the A and just show you it doesn't matter. So 3.9, and we'll square it, is 15.21. We still don't know what B squared is, and 11 squared is 121. Now we need to move this over here to isolate the B. Okay, and so that's going to, see what happens is we're left with B squared, and we're left with whatever 121 minus 15.21 is. Okay, is 105.8. And what should, main thing too is don't forget this is still squared. If you were to put 105.8, that should, ring some bells as far as that being a really small side, that being, 11, and then all of a sudden you've got 105. That should tell you, wait a minute, that's way too big. So it reminds you that you still need to square root 105.8. So we're going to do that. And it's 10.3 rounded to the nearest tenth. And see, that makes more sense. If this was 3.9 and this was 10.3, that fits into the lengths of the triangles, okay? All right, so let's go through and do these. 6.5 squared plus b squared equals 9.9 squared. So 6.5 times 6.5, 42.25 plus b squared equals 9.9 squared, 9.9 squared, 98.01. And so to solve, we're going to move the 42.25. So b squared is going to equal 55.76. And then you just need to square root that. And it's 7.5. So that side is 7.5. Okay, let's do one where the a square, we'll make it a squared that's missing. Just to show you it doesn't matter if it's a or b that you make the missing side. It's your choice. It doesn't matter each one. Okay, as long as you don't make, as long as you keep that c squared. Okay, so 9.7 squared is 94.09. And 13.3 squared is 176.89. Okay, and we need to subtract these. It's 82.8. Okay, and then we need to square root it to solve for a. Is 9.1. Okay, then we go back to one that is the hypotenuse missing. Okay, so now they're mixing them both together. So 5.2 squared plus 9.2 squared equals c squared. Okay, so we go back to that if the hypotenuse is the one missing. So 27.04 plus 84.64 equals c squared. Okay, so now add those together. So 111.68 equals c squared. So I just added those. And now I need to square root it. So 10.6 equals c. This side is 10.6. All right, same thing with this one. 2.7 squared plus 6.5 squared equals c squared. Because you're missing the hypotenuse again. Okay. So 2.7 squared is 7.29. Okay, and then 6.5 squared is 42.25. So we need to add these together. 49.54 equals c squared. And then we need to square root it. 7.0 or 7 If we're rounding to the nearest tenth, it's 7.0, so 7. Okay. Last two is we're missing legs again. So let's make this one a squared plus 5.3 squared equals 7.2 squared. $28.09 and 7.2. Oops. 51.84. So we have this a squared plus this. So our one extra step is we got to move this over. So that we get $23.75. Okay, and the last thing we need to do is square root it. So 4.9. So as you're seeing, it kind of falls into a pattern. You know, just whether it's the hypotenuse missing or leg, that's the key point. So on this one, we'll make this a, so 2.7 squared plus the missing b squared equals 6.5 squared. Okay, and so 2.7 squared is 7.29. Okay, and then 6.5 squared is 42.25. And then to isolate b squared, we're going to subtract. Is 34.96, and then all we have to do is square root that to get 5.9. Okay, so as you see, like I said, be real careful. Now these two problems here I put on purpose. The Pythagorean theorem, you know, we could get abstract and think, well, this is only good with triangles, and why, you know, what am I going to use? Well, they use the Pythagorean theorem a lot in everyday world because we have a lot of right angles in our world. Here's an example. This is a building, okay, and a building, if it's straight up and down, you know, and put little windows here and little people, you know, and they're working because everybody works inside now and they're waving. But you've got this building, and it forms a 90-degree angle with the ground here. Okay, and let's say the building is 20 feet high, and you've got this ladder that's 15 feet out here, then how tall does the ladder need to be to reach the top? So here we form this right triangle, and we can use the Pythagorean theorem. Okay, we've got our legs, so we could say 15 squared plus 20 squared equals whatever our ladder needs to be. Okay, and so 15 squared is 225. Okay, so 225 plus 400 equals c squared. Then we add them together. And then if you take 625 and square root it, you get 25. So the ladder would be 25 feet tall. And you could do that all different ways. You could know how tall the ladder is and need to know how tall your building is and just work completely around that. Another example is, you know, when I travel and I go to these cities and stuff, you know, we know directions are straightest, you know, with a straight line, but a lot of times you got to go around buildings, or maybe you got to, in the country, you got to walk around a park or something, and you want to know what's the straightest distance or how far do you live from something here. If you have to walk in a straight direction, then turn on the sidewalk and walk this way, you can find this distance by knowing these distances here. And they use that in construction, road building, and stuff like that. So right triangles are very useful. So in this case, you know, you do 21 squared plus 28 squared would equal this length that's missing here. So if you walk 21 feet south, 28 feet east, then how far are you from your starting point? Okay, and so 21 squared is 441. And yes, I am using a calculator on that. 28 squared is 784. Okay, and then you just add those two together. and you get 1225. And the square root of that, okay, should be 35, I think. Let's check. Yep, 35. Okay, so that's this length here. So those practical applications that you could use in Pythagorean theorem as you go on. And so I want to put those on there to kind of take it out of the abstract here. So anyway, watch this video, check your answers, and then the study guide will be pasted with this on as a photo, and then the next day you'll get your answers to those so that you're ready to study over the weekend for your test. Okay, thanks guys.